Let's talk about how to approximate limits using our handy-dandy TI-84 plus CE, or plus without the CE, or 83, or Silver Edition, or Chocolate, or Vanilla, or Neapolitan. Say we've got some function that we want to know a limit of. We'll put it into y equals, that way we can kind of call it a single function. We press that y equals button. And let's do something like parentheses 1 plus x over 2 and parentheses all raised to the power of 1 divided by x. I choose this function because I know I can't plug in 0. I can't do direct substitution with 0. If I do direct substitution with 0, I get 1 to the 1 over 0 power. 1 over 0 already, I know I can't do direct substitution, but even if I think about that as like infinity or negative infinity, if it's infinity, 1 to the infinity, that's indeterminate. Seems like a good candidate to try some limits with. First thing we can do is, it's in y1. Instead of graphing y1, I can look at a table of y1. Table's in blue above graph. That means that if I press second graph, I'll see a table. If I want to use the table, though, I need to make sure that I'm in control of the x values in the table. So before I go to this table, I'm going to do some table set. I'm going to do second window. And I want to make it so the independent variable, the x, is something that it asks me. So I'll go down, go to the right, and press enter to choose ask. That way I'm in control of choosing x. Now I'm ready to go to my table, so I'll press second graph. I see my table, and I can punch in any number I want. We're interested in that function near 0 because that's that number that we know we can't do direct substitution with. Maybe I'll say something like, well, let's get close to 0 on the left, like -1. If x is -1, I get 2, okay? What about if we're even closer on the left, like -0.5? A little smaller, -0.1. -0.01. And then we say, oh, we're impatient, let's stop beating around the bush, 0.000001. And we get 1.6487. I can't really see if I've kind of hit a stopping point unless I go even closer. Let's see, -0.1, 2, 3, 4. Okay, I'm convinced. This is very, very close to 0 on the left. It definitely looks like the limit on the left approaches this number, 1.6487. If I want to know even more exactly what it is, I can go over it, 1.648721. If I'm curious if the limit from the right is the same, if the limit overall exists, I could try numbers on the right, like 0.0001, or even just 0.001. It looks like this limit is, it does exist. It's something like 1.6487, which looks familiar. I think it might be the square root of e. This is one way to do it. Oh, I've got some time. 3 minutes, 30 seconds. I've barely given you a video. Let's look at another way to do it. I'm going to do second quit to get out of here. And I'm going to clear off all this junk so that you don't have to look at it. Clear that off. We still have the same function in y1, remember. It's in the function y1. I can use y1. If I press alpha trace, it'll take me to f4. And I'm able to see my different y variables. And I'll say, oh, okay, I want y1. I either hit enter on this one, or I'll select the 1. I can use y1, and I can plug any number into y1 using function notation. I can say, what is y1 of 0.01? Or I could say, what is y1 of 0.001? Whoops. I left out a parentheses. What are you talking about, divide by 0? No, I didn't. Oh, I did a little decimal there. Okay, so I'll do second, enter, pull it back up, get rid of that straight decimal, put it instead here, get that number. By the way, alpha F4, that works for me. I'm not convinced it works on all the flavors of TI-83 and 84. If it's not there, you can always do variables, y variables, function, y1, and that will accomplish the same thing. You also, once you've typed this in a few times, you don't need to keep bringing it up. You can, you don't need to keep doing alpha F4 or doing vars. You could do second enter, pull up the last thing you did, scroll over, stick another 0 in there. Okay, but you know all this because you're very smart. I can tell through this computer. You're that intelligent. It bleeds through the computer screen. 6 minutes in, let's look at it another way. This one's a little more graphical. So we know that if we look at our graph, that's the graph of the function we're interested in. We can kind of see a little gap in it at 0. I think that's what I'm seeing. It could just be some sort of a remnant of how the computer processes the function. If I do trace, I'm able to plug in whatever number I want. If I do trace, I can scroll around the function using the arrows, or I could type in a number. Like I could say, oh, I wonder what it is if I do 0.1, or do 0.01, or do 0.00001. And that way I'm able to get a good sense of what y is converging to as x approaches 0 from the right. By the way, this 1.6487, because I'm doing it on this screen, that is now what the variable y equals. Like if I were to get out of here and look at alpha, what y is at this point, it'll tell me that. Or even if I were to just look at what, if I don't use function notation, just type in y1, it gives me the last value of it. If I had tried evaluating it to 1.414, if now I ask for what y1 is, I'll get 1.414. Okay, that's me just circling around 100 different things. Hopefully now you have a little bit better sense how to use the calculator to figure out limits.